Welcome to the Productive AI podcast, where we aim to simplify AI and make it more accessible to business leaders. I'm your host, Troy Angradon. On today's episode, we're going to be talking with Seth Clark, who's head of product for a new platform called Modzy. And we're going to be talking about what is involved in building and delivering AI applications at scale. What are some of the challenges in doing that, and some of the solutions that his team has come up with in that area. Seth, thanks for joining me on the call today.
Oh, Troy, it's a pleasure. Excited to talk about this stuff. We spent a lot of time thinking about how to help people use artificial intelligence, actually get some value from it, and excited to talk with you more about how we might do that.
Great. So let's talk about the we in that sentence. Now, this is actually, the company is not really called Modzy. That's the platform name. And the company is maybe a surprising company to folks in the AI space. This is not a little startup. This is a very big company, and this is a startup inside that very large company. Can you tell us just a brief bit about that kind of background?
Sure. Yeah. So Modzy, it's an AI and ML platform that was really born out of years of data science, and before that, operations research experience from Booz Allen Hamilton. So, from our consulting heritage, those of you who aren't familiar with it, it's about a 105-year-old company, 26,000 people. And we do a lot of work supporting the U.S. federal government, a lot of work across the international realm, various commercial industries, particularly around cybersecurity and data science. And over the past couple of decades, really, as machine learning has taken on a larger and larger role in operations research, optimization of sort of business decision making, and in some really tactical stuff as well, we started doing a lot of the same stuff again and again for our customers, our clients. And when it comes to deploying machine learning in a way that can actually add value and move a mission forward, solve a business case, solve a business problem, there are all these hurdles that were taking just huge amounts of time to overcome every single time we were trying to take a machine learning model and put it somewhere where it was going to add value. And solving the same problem, 100 times in a row, not that much fun. And we thought that there could be a better way for us to do this in a way that would, add value to a whole lot of the customers that we serve. And that was really the genesis of Modzy. We saw an opportunity to really just improve that experience and make the lives of both data scientists and software developers a lot better as they work together on making machine learning, return some investment.
That's awesome. If you're familiar with the lean startup approaches, there's a principle in there, which is if you're thinking of building a product, do it as a service first. And that's where you learn all the hard lessons so that you can then turn it into a product. So you guys have completely followed the lean startup approach on this.
Yeah, I think that's one of the benefits that we have going in is a lot of our own, pain points, scar tissue, discoveries from actually helping clients do this a lot of times in a row was really the foundation of us saying, yeah, there's a problem here. We really know it pretty well in our bones, and have some interesting ways of thinking about it. So that's exactly where we're coming from.
What kind of customers are you mostly working with? Now, Booz Allen, of course, traditionally has worked with defense and government, civil government, as well as large enterprises. Is that kind of the same mix of customers you're looking at working with Modzy?
It's certainly a big part of the customers who are most interested in what we're working on. A lot of customers across the Department of Defense, the intelligence community, civil government have just huge volumes of data that they're using for decision making that even to this day is still very human powered, that decision making process. Even to the extent to which analytics are being used, they're still being done in a what you might call human in the loop process. So, opportunities to take the human out of the loop when it's not necessary, when you can have a computer making those decisions, discovering those insights that can be used to move some mission forward. Certainly really important across the US government, but we're seeing a lot of interest in commercial industry as well for operationalizing their business through the use of AI in a totally new way. This includes the finance space. This includes oil and gas, energy and utilities, the insurance industry. There's a lot of spaces where, I think there's a very kind of a aggressive lean towards using AI, but in some of these more regulated industries, at the same time, an understanding that to use AI effectively, you have to really look at it holistically and understand how it's going to impact your business as a whole. And you can't simply buy something off the shelf and expect it to work right out of the gate. So, I think a lot of the commercial industries that have similar sizes and footprints and use cases to the government are finding a lot of value in what we're putting together too.
What is it that kind of drives those customers to look for a platform, something like this? Is it just that it is expensive and it's hard to do at scale? It's like, what are the issues? Is it management, governance, security, model building? What are the core problems that they have that make them look for something like this?
There's a lot of them. Everything you listed is absolutely a problem that we've talked to a different customer about. I think that the simplest, most straightforward problem is this idea that machine learning models are done today or developed today in a very R&D lab oriented type of context. Typically, oftentimes they come out of R&D environments. They're coming from major universities, research institutions, research arms of really big tech companies like Google and Facebook and Amazon. And so it has this sort of prototyping. There's always a new framework every 2 weeks. There's 10 new papers coming out of 15 conferences every day that are constantly evolving machine learning, which is exciting and makes it a very fun field to be in. But the work required to take a really cool idea in a paper from CDPR and put that into a production system that's being run against real-time data, there's a huge amount of work needed to do that. And most companies fail at that process. And that's where we see that ROI gap, where you're spending a lot of money and time building up a data science team of really smart people building these models, but they'll often then get stuck before they can get into production and start adding value, start getting used for a real useful purpose. Modzy is really built around the idea that we want to help get those models out of the lab into production. And as part of that, surround them with the amount of security, governance, auditing, management tools that a large enterprise needs in order to really effectively use IT.
And I would imagine that when you're doing that, you're going to get, well, let's talk about the team. Like when you're putting together one of these projects, who are the different players on that team, right? From the execs to the data scientists, and there are others. How do you think about that?
Sure. So typically the champion will often be, a leader in a line of business. So you have someone who's responsible for one specific part of an organization. This could be in the energy and utility space. This could be someone who's responsible for calculating and predicting demand from renewable resources over the next 10 years. How do you do that? That's a really complicated problem.
Right.
So there's a line of business leader who has this underlying business need, and they need new and compelling ways to solve this problem, to predict renewable energy generation. At the same time, then, on the technical side, you'll often have data scientists who are the mathematicians, the experts in understanding how to take data and get value from it. You'll have software developers who are building integrations, building applications that might use these models. And then you'll have senior executives, thinking of the CIO and the CTO, who are responsible for creating the environment and the ecosystem and putting the tools in place so that all of those players can actually collaborate and create something of value together. So it's interesting, AI in particular, because collaboration has to go all the way up and all the way back down the chain at both a very high level strategically, but tactically there's some really, really important tactical stuff that's happening to make AI add value as well.
So what is this thing ultimately? You describe it as a platform and a marketplace. We'll unpack this in a second, but the line I saw was a platform and a marketplace with embedded security, adversarial defense, and governance that helps enterprises deploy AI at scale in a trusted manner. That's a lot. So if you could sort of break that down, that would be really helpful.
Yeah, happy to do so. I think we can kind of simplify this in terms that as a business leader, as you're thinking about how to use AI, maybe this is a more helpful way to think about it. Traditionally, when people used to build software applications, they were built in a way we call them today as monoliths. They were monolithic applications. So you typically get a bunch of software developers together, a bunch of requirements analysts. The requirements analysts would create giant spreadsheets with a list of everything the application has to do. And then the software development team would spend 3 years building it. And by the time that 3-year period was over, you'd have a piece of software that probably wasn't useful anymore. That was monolithic software development. And what we've seen in the software development realm, independent of machine learning, is a transition to a much better approach, which we think of as the service-oriented architecture and microservice approach, which is to say there's lots of smaller pieces that can work together to create value, to create a system that can do something really helpful. But the value of it is you can move a lot faster. You can adapt much more quickly. You can create components that can work with code you wrote 15 years ago while still adding to that system. So what we've done with Modzy is tried to bring machine learning to the level that it can work in the same manner as all of these other modern software applications are operating. So we're essentially taking machine learning capabilities and turning them into microservices that you can then use, deploy, manage, update, rather than over the course of 9 months, which is the average amount of time it takes to take a model from your laptop and put it into production, into a couple of hours. And this gives you the ability to not only embed these capabilities into systems where they're needed, case management systems, marketing integrations. There's a whole range of places where machine learning can add value. You can now start doing that much more rapidly. You can react to changes in customer demand, changes in the market that require you to actually update the model. You can now update those models within hours or days. And the whole concept is really meant to speed up the process with which machine learning can start adding value. So in a nutshell, we're really making it possible for you to start embedding AI across your entire enterprise in a much faster, much easier, and much more maintainable way. And as part of that, we take a really serious stance towards security. We think security, governance, auditing are essential parts for an AI system to really get the amount of trust that's needed for it to make an impact across a big enterprise.
And in addition to security, you guys often talk about speed, scale, and choice. What do you mean when you say those things, kind of as a group of four?
Sure. So speed is really in reference to two things: the speed in which you can now start getting models and using them in production systems, using them across your enterprise. That's an important speed for us. We don't want people to take 9 months to make that happen. I have an anecdote from a friend of mine who was working for a customer, a client of hers, where they built this really sophisticated text topic modeling algorithm and spent about 8 months trying to tie it into the case management system where they wanted to use it. 8 months of work trying to get this model to run in this case management system ultimately failed. They could not get it to work with this sort of antiquated system. And it was just a really unfortunate and painful story to hear, because she had put months of work into creating the algorithm and then spent even more time trying to get it to actually, work with this old system. And because of the way that this organization's infrastructure was set up, it was a fool's errand to begin with. There was no way it was going to happen with the way that they approach software development and machine learning. And those are the kinds of stories that hurt me. And make our vision even more focused at Modzy to try and create something that can address that. So speed is in one sense focused on the speed at which we can make those models useful, as well as the speed at which those models can process data. And that ties into scale as well. One of the aspects of machine learning that's unique compared to other just cloud applications is that hardware decisions are very, very important. It can really make or break how useful and how quick the machine learning systems that you put into production operate. So it means you have to have really good decision making around how much hardware and what type of hardware, from CPUs to GPUs to FPGAs to ASICs to TPUs. We can play the alphabet soup of hardware specs, but those decisions are really important. And so for us, scale is about making sure that the IT department has the tools in which they can, think of it, turning up the volume to say, we need more hardware across the board in order for this system to perform at the level it needs to meet the business needs. And at the same time, have the tools to say, there's a maximum amount of money we can spend in order to get that level of performance. And so one of the things Modzy does is provide those tools to help you optimize speed while managing the costs associated with a lot of hardware being used to run these models. And then choice is really around an architectural decision that we made for Modzy to be focused on integrations. We want the system to be very easily tied into whatever production systems you want to add AI into. So this means we can connect to the training systems you use, and we'll talk more about what that looks like, what model training is versus what we call inference. as well as the systems that are using those outputs. And that kind of choice really helps an organization that has made some decisions about their IT stack very easily integrate machine learning into whatever investments they've already made without having to buy everything again from scratch. We don't think that's very effective or efficient.
Could you walk through the pipeline kind of from initial data, sort of acquisition, sourcing, cleanup, and feature development, and maybe explain kind of what that is at a very high level, and then into more of the sort of what is now being called MLOps, but really essentially provisioning some infrastructure, developing a model, training that model, debugging that model, deploying that model, and monitoring that model. That kind of set of steps that happens in this process in order for somebody to get to full production, including some of the other stuff you mentioned. You talked about costing analysis or retraining or things like that. So if you could just kind of step through those steps and where you play and don't play, just so people go, okay, I understand which problems you're solving, which parts of this process you're working in.
Absolutely. I come from a consulting background. So for me, I like to go back to first principles. And I think an important first principle for any analytics or data science or AI engagement is have a good problem to solve. I don't think we could overemphasize how important it is to pick a problem that is useful and actually solvable. And so spend as much time as you can being really selective about what problems you're trying to solve. Machine learning is not a panacea. And I think anyone who tries to tell you it is selling you something that you probably don't want. So choose a good problem. Once you've done that, then it really comes time for the exploration phase of looking at what data assets you have available to you, whether those are open source data assets, data you could purchase from somewhere else. But for most organizations, the data they have in-house. Whether that's workforce data, whether that's marketing leads, whether that's operational data from customers that you're serving, really giving a data scientist the opportunity and the time to explore that data and understand what can be mined from it. So problem identification and exploration, that sort of gets you to the beginning of really the meat of the machine learning process, which then comes building a model. We call that model training. There's a lot of different terms for these phases, so I'll use the ones that I think are most common, but you may hear other terminology. Model training is really taking historical data, choosing a math equation, and telling that math equation to look at this historical data and update itself continuously until it can relatively effectively model that historical information. So if historically all red cars get speeding tickets, and you look at enough historical data, your model should be able to take in the parameter red car and output, speeding ticket equals yes. That's that process of training. And as you start to do it with really complicated things like computer vision models that are doing it with, video footage or radio signals, you can apply machine learning to just about any kind of data you can imagine. It gets really sophisticated. So that process is really the domain of data scientists and where a lot of the great innovation is happening. So once you've done that training process and you've then evaluated that model, basically tested it to see if its predictions are consistent and it's relatively accurate and relatively performant, this is where really MLOps starts to kick off then. What comes next is starting to put in place the pipelines that automate the process of then taking that model that's been trained and moving it through a series of steps so that it is now in quote unquote production. And that can often mean, in some cases, containerizing that model. So it can operate in a container-based architecture, running it in a system, something like Kubernetes, that can run what are called pods of software, giving you the tools to scale them up and down. This includes putting them in a system that allows you to monitor the usage of that model over time. So that could either mean watching what kind of data is coming in. This could mean monitoring the performance of that model over time. In some cases, that might be a statistical output. You'll often hear that called model drift. And it's basically a math formula to tell you, hey, the input data we're seeing has changed enough where your model may now be out of whack. We're not seeing cars anymore. We're only seeing helicopters. So your car speed detector model is probably not going to be doing you very much good. And then there's also human feedback that you want to collect too. So if you're using text topic modeling for customer comments on your website, and your customer success team is really upset about the responses that are being auto-generated. That's another good piece of feedback. So that then loops back into the model evaluation and retraining step. So MLOps is really kind of the process of taking data, creating a representation or model of that data, moving that model into a space where it can then run against huge volumes of data in production, and then watching that information so that you can figure out how to continuously improve that loop. And the more sophisticated you are at machine learning, typically the tighter the time scale of that loop. For really big companies, I have friends who work at places like Facebook and Apple and Google. That loop can be within a single day. The retraining can happen overnight sometimes. For organizations that aren't working with data that's moving minute by minute, sometimes that cycle can take a month, 3 months, 6 months, a year. But I think the important part is if you're really doing MLOps correctly, you're creating a cycle and a loop where you're constantly improving the systems that you've deployed.
One of the things that I noticed in your language on the website and some of the documentation is you guys talk alternately about model management, which I think is at the highest level, but correct me on this, and then MLOps and model ops. Can you sort of help maybe distinguish those terms and put them in relation to each other so it's a little more simple?
Sure. And I'll give myself a disclaimer here to say I'm not an expert on all these terms as they're evolving really quickly. Some of this is from our experience, terminology we use. Some of it comes from Gartner is actually starting to try and standardize some of these terms. I think model ops is at a high level. So model ops is really the whole process from I've identified a problem and I want to start exploring data and then going through that whole loop. And now I have this model that I'm continuously improving and evolving over time, and really treating that model as something that has a long lifespan. We see model ops as that highest level item. And then MLOps is really the kind of the sister of what we think of as DevOps. So those of you who are familiar with software, DevOps is just the automation of stuff that software developers used to do by hand. So anytime you can do something automatically, commit code to GitHub, and it automatically kicks off what we call a build process to then create a new version of your software, and then push that up to a cloud environment, and now it's live. When you can push one button and all of that stuff happens automatically, that's DevOps. I'm probably killing all my DevOps friends for trying to simplify their jobs in that way. But the same idea for MLOps. It's really that automation process of making that flow really simple.
In terms of building and deploying these models, so let's say a customer is using this platform and they want to build a model, develop that model, train it, and then essentially deploy it to production somewhere. Now, what's interesting about you guys is you can actually deploy to what you call the tactical edge, or I'm not sure if you also just refer to edge like car or factory, but definitely tactical edge to the cloud, to a data center, and to an air-gapped data center. Now, some people might not know what that is. So could you just kind of quickly take us through those 4 deployment locations?
Sure.
For where the model might live? Yeah,
absolutely. One of the sort of base decisions we made really early on is supporting machine learning wherever it's happening. There are different tactics you could take, including having a SaaS-based model. And what we found, both certainly within the federal government, but even in commercial industry, the kinds of systems and the kind of data upon which machine learning is running tends to be your gold mine. That tends to be your most valuable asset as a company. And a lot of companies are very reticent of throwing that gold mine data into public cloud without having full control and security over it. So we took the tack to say, if you want to deploy Modzy and manage your models in the cloud, excellent. We will support that. We'll make it possible where within your environment, so if I have my own personal AWS account, I can deploy Modzy within that account. Same with Azure. We have other cloud providers that we'll be supporting coming soon. We can do that. That's excellent. If you have your own on-premise environment, you have a physical set of hardware in an environment you own and manage. It's connected to the internet, but it's behind your locks, your gates. That's great too. We can provide mechanisms for you to deploy that within your controlled environment. We can also support environments that use VPCs to kind of cross that gap. They're often called hybrid clouds, where some of it's on your environment, some of it's in a public cloud, and you get a little bit of the best of both worlds. And it also means we can deploy to spaces that have no connection to the internet whatsoever. This could be a 1 or 2 U server in a rack in a closet somewhere that's in a an oil derrick offshore somewhere. This could be on a ship that's moving around the world. This could be in for the military for a deployed base. There's a lot of spaces where machine learning can add value, but there isn't necessarily a data center immediately available. And that's where we start to get into what you described as the tactical edge, finding ways to make machine learning accessible in spaces where huge amounts of bandwidth and huge amounts of hardware are not always as easy to come by. So, we've really focused on trying to find valuable ways to help our customers get access to some of the models that they can use in those environments in a form factor where they can, take advantage of those capabilities with whatever hardware footprint they have available.
Okay, so the picture we have so far is you've got all these very large organizations. You've got this really big buying team, this AI team wearing their jerseys. What are the sort of big, high level, what's the one sentence takeaway for each of those different team members? For the executive, let's say the overall executives versus the line of business executive versus maybe the technical execs and or the business analysts, data scientists. What's the kind of one line, wow, this is the outcome I got, the value I got from us using this platform?
Yeah, so I'll start from kind of the bottom of the team in terms of sort of technical execution all the way up through the executive chain. Perfect. And sort of how we built Modzy to support those folks. For data scientists, what we really wanted to focus on is providing an environment where data scientists can focus on what they do best, which is mathematical modeling and model training. It's an incredibly complex process to understand how to build a fair, accurate, and robust algorithm that is not overfit on your data and can consistently produce good outputs. That is really hard. That's a full-time job. And often what we do is we ask data scientists to then also become infrastructure engineers, machine learning engineers, part-time software developers. We're adding work to their job jar that's just way out of scope and is putting way too much on their shoulders. It's unfair, to be honest. And so what we want to do with Modzy is say, all right, data scientists, focus on what you're really, really good at, and that's making models. And then let's have a handoff. So with Modzy, what we focus on is having a handoff where once you've trained a model, you can then package that model and deploy it into Modzy. And now you've completely given away that model in an environment where software developers can now access it and use it through a format they're used to using, which is through APIs. Software developers can then consume these capabilities, consume these models, build them into web and mobile apps, tie them into production data pipelines, add them into your own custom systems. And they can do that in through a mechanism they're used to, which is just calling APIs. It's a really simple mechanism that also means data science or software developers don't have to learn PhD level statistics. They can hand that off to the data science team and say, I trust that your model is doing something amazing, and I'm going to focus on just engineering the data into this model and getting the results and putting them on a screen. So it's really meant to give those two teammates at a tactical level a better place to play the sport of data science. For program managers, I think the value proposition that we start to see, line of business leaders, program managers, is faster iteration. You're able to get your mission moving forward a lot more quickly, get models into production, prototype those models, quickly iterate through improvements and advancements to those models, and really simplify the acquisition process. Through something like Modzy, we built a mechanism where you can now tie in commercial algorithms that you might want to purchase. We have algorithms within Modzy that are purchasable independently. You can build your own custom models that are really bespoke to your own data. You can build in open source algorithms, and you have a central place of managing all of those capabilities, which means you can kind of Lego brick custom solutions from a lot of disparate parts. And for senior executives, I think it's really about risk management through the tools we put in place around security, auditing, and governance. Really, no one can misuse an AI system without a clear trail of exactly what happened, who used the system, how did they use it, what data did they process, and in the situation where AI makes a mistake, and it absolutely does, and it will continue to make mistakes, being able to have the data to support that after action report, to be able to do a hot wash and evaluate, all right, what went wrong and what can we do as an organization, as a company, to fix this. Modzy is really focused on providing the mechanisms so that you've got all of that data at your fingertips. So for executives, that risk management, I think, is a huge, huge plus.
And I would think that the additional thing for the executive team, certainly for the CEO of the organization or the lead, let's say the leadership team of the organization, is just time to value for any of these things. If you're doing this all by hand and you're stitching together all these systems, and let's say you're making your data science folks learn coding and your coding folks learn data science and statistics, and making both of them learn infrastructure, that seems pretty inefficient. So it sounds like at the end of the day, the roll up here for the executive team is do more experiments faster, or validate these experiments faster, or maybe build an AI that is working in production at scale, delivering some predictive value for supply chain or for retail that gets them some large return on investment for this entire thing. We kind of touched on it, but I think that this model marketplace is super interesting. It's essentially, and I'm sure you guys, I don't know if you use this language, but it's an app store essentially. Except it's a model store. What was the rationale for that? Why buy it from a store? Why not build it yourself?
Sure. So our model marketplace is really meant to provide easy access to commonly used algorithms that are often needed by a range of different use cases. So, if you think of use cases from broad to narrow, at a broadest level, there's very frequently, for especially multinational organizations and corporations, a need to manage text and content in multiple languages. To be able to receive comments and feedback from one language and be able to work with it in another. So one of the things we did was say, why should company X build their own language translator from one language to another? What's the value to their business in investing in something so broad that could be brought by another company that specializes in that area? So we have partnerships with companies like AppTech, which is really one of the world leaders in language translation, both spoken word as well as text. And they bring a collection of languages. I think it covers something like 45 or 50 different languages that they can do sort of real-time language translation in both spoken word and text back into English. So for someone who's working on creating a system to manage multilingual, customer feedback, choosing to purchase a solution like that is absolutely the best business value. There's no reason to build that in-house. Alternatively, there are cases where if you're building a optimization algorithm for a trucking company, it's probably going to have to be built on your own data because it's your company, it's your trucks, it's your supply chain. That's going to be a model that needs to be built in-house. So what we wanted to do with the marketplace is provide a mechanism where organizations can pick and choose and make those trade-offs for themselves, identifying algorithms that they can be used out of the box to add value to their systems, while also being able to create and build their own algorithms and add them to their own internal model stores. So you get this kind of combination of buy versus build. Well, you get both, buy and build, where it makes sense, and we think that that's going to help really accelerate time to value, as you mentioned before, and that comes from our experience doing this for consulting customers, having built the same model for 7 different customers 7 times in a row. Our data scientists get a little tired of doing that again and again and again. So why not provide something that multiple people can use in the same way?
One of the things you talk a lot about inside kind of the overarching, I'd say the umbrella of security and trust and governance, generally speaking, you've got kind of a subset that you talk about, which is adversarial defense. So can you just explain maybe what that is, why it's a thing, what the attack vectors are, and what you're doing about it, and kind of just expand on that whole section?
Really, the idea is that neural networks, the way they're created, the way that we train models today for a lot of particularly computer vision and natural language oriented models, basically do a bunch of matrix math. And they take in a bunch of inputs and they do a bunch of matrix math, and then you get an output. And it's an incredibly effective way of modeling some pretty sophisticated systems, but they have drawbacks and there's weaknesses to them. And those weaknesses can be exploited by a suitably savvy adversary. And this adversary could be, just someone who's, you think of them as a gray hat, machine learning hacker who just likes to kind of cause trouble for fun. or truly an adversary who's trying to take advantage of your organization, of your business, cause problems. What can be done is essentially with manipulations to inputs, you can force a model to make mistakes. We have some examples that we've shown of being able to take an image of a personnel carrier, a military personnel carrier, change a few pixels of this image, and the model all of a sudden thinks that it's a passenger car. It's so slight that a human eye would not even be able to detect the change. But if you're using machine learning algorithms to do sensing around the world around you, you can imagine for autonomous vehicles that's really risky. These types of attacks can happen both in the digital world where you're tweaking pixels, but even in the physical world. You can put a sticker on a stop sign and a car all of a sudden thinks that it's a 45-mile-per-hour speed limit. Imagine the havoc that can cause. So adversarial defense research is really focused on how do we create models that are more robust is the common term. At Modzy, we've developed a couple of different approaches that we've actually patented that allows us to train models in a different way in order to identify and basically remove those weaknesses that are built into the model. All of these attacks are based on, poking at a model from a bunch of different angles in order to find where it's weak and then exploiting that weakness. And adversarial defense really focuses on trying to create models that don't have those weaknesses built in. One of the other side benefits that comes with these adversarial approaches is it also makes models that are much more resilient to change. So even outside of a context where you have a bad actor trying to manipulate your AI, it also means that if you start receiving input data that looks a little different than what the model was trained on, that model is typically much more resilient and much more capable of handling that change and still producing good outputs, still generating good responses, even if it hasn't been trained on that data. So there's some side benefits that come along with this new approach to AI security.
The next one I wanted to ask you about was the explainability issue. Now, this is a big thing, of course, in AI, which is, how did it make the decision? It's a big black box. You guys are doing some work in that field, including trying to speed up how explainable you can make this. Can you just kind of explain why is this hard and what are you doing about it?
Sure. I think I'll start with why bother? Why bother explaining a model? And I think it's a tricky and interesting question that will probably change as society and humans in general get more used to the idea of computers making decisions for us. And there's a lot of places in life where I trust a computer to make a decision for me that I've comfortably given that over. Google Maps or Waze are my favorite examples of this. I generally know roads where I live pretty well, but if I'm on a road trip, I'm doing exactly what my smartphone tells me to do. I have no second guesses about it, no qualms at all. That's an amount of decision making that I've been comfortable giving over to a computer that's using artificial intelligence to try and find the best route for me. In other spaces, other missions that are really much more sensitive, much more important, things like loan approvals. I don't think we as people are ready for computers to do that automatically, especially not with respect to which bias still exists in models. And it's going to take us a long time, I think, as a field to find good solutions to that. So explainability is really about helping to provide explanations to humans about how a machine learning model came to the decision that it came to. And it can be used in a couple of different ways. It can be used to either help validate a prediction and provide some context so that a human being can say, yes, based on the decision that was made and this input that I've been given, this explainable context, I feel confident that this is the right decision. In other cases, it can be used for after action reports. Again, when something goes wrong, you now actually have a little bit more understanding. You're able to peek through that black box because otherwise, all you're left with is just a bunch of numbers. And it's really hard to interpret a weights file and understand what that's trying to tell you. So explainability in both imagery and text are mechanisms that provide feedback to human beings that allow us to just better understand what these models are doing and why they've done what they have. And at Modzy, we focused on computer vision first, an area where there's been a lot of research, but the research has generated solutions that are still pretty slow. And as a result of being slow, they're hard to use in production. There's just not the time or resources to take advantage of these explainable outputs. in a way that doesn't hamper your system's performance. So we've developed a new solution for explainability that's sometimes 10 times faster than most of the other solutions out there. And we think that speed means you're going to be able to take more advantage of those explanations, make them available to business users, to analysts, to decision makers, as well as have them available in your kind of logging system. We've also focused in our next area of research around how to do that with language as well, and doing things like text summarization and topic modeling on text can be really tricky and complicated because language is really tricky and complicated. And so that's another area that we're working on to try and help provide a little bit more context for someone who's trying to understand how did a machine learning model make this decision.
And for executives and leaders who are thinking, hey, we want to start applying this kind of technology, we want to start solving some business problems. This is one of the risks. There are risks inherent in building any technology, but certainly one that is going to ingest a whole pile of data and then come back with some sort of predictions, which you're going to base business decisions on. And so one of the ways that I've heard folks using this is essentially having human auditors, and they will go in and look at, some sample of the output or the results and say, how did we make, and then they want to know, how did we make this decision? They see the decision that it made, but I want to have it almost explained to me in human terms. A and B and C were the three critical success factors that led me to say that this loan should be turned down or should be accepted.
Yeah, that's a great example of the kind of scenario where explainability can be useful. And I do think, as I mentioned before, it's an area where as we as humans get more used to the use of AI, it may not be so necessary, but especially as you're looking at the change management aspects of rolling out AI into a large organization, this is an important topic to consider as an executive. How are we going to create an environment where both our customers and our employees are comfortable with this giant transformation? And explainability can be one of those tools to help with that change management.
Who's the ideal customer for something like this?
I think more so than the size of the company, headcount, dollar value of annual revenue. Those are kind of secondary variables to us. It's really around where the customer is in their machine learning journey. And I think customers who have made some investments in machine learning, have hired a data science team, have gone through the process of trying to create some models, and have actually struggled with some of the challenges of taking those models and putting them into a production system. Those are the customers that we find are great partners, and we'd love to work with. It often takes, you kind of have to learn the hard lessons yourself, in my experience, of actually trying to go through the process and understand, what does it take to try and do all this stuff myself? What does it take to try and build a team to create all of these steps in that model ops and MLOps process manually? And how much difficulty has that cost us, and how much has that slowed us down? I think for an organization that's tried that once or twice and realizes there's got to be a better way, we would love to talk with you, because we think we have some ideas that could help. And an organization at that level has already probably done much of the work to figure out the places in their business where machine learning can really start adding the most value and really produce the most operational efficiencies and workforce productivity.
So less about size or sector and more about state of their organization in terms of AI readiness or AI engagement or competence, and just generally maturity.
Yeah, I think that's right. I think we're really focused on helping organizations that are looking to take that next step from machine learning prototyping and experimentation, which is it's the first step and you have to do it. Folks who are looking to go from that experimentation step to truly starting to move things into their core business, and we want to be partners with customers who are taking that step.
What would a customer do if they did want to connect with you guys? What would be the best path?
Contact us on Modzy.com. We've got a lot of resources there to help you learn more about what Modzy does and some of the industries where we have solutions tailored for that industry. But just talk to us. We'd be happy to chat with you, set up a demo, and just learn more about what kinds of problems you're looking to address that something like Modzy could help solve.
Perfect. And I'm assuming once they did that, go through the demo, talk to one of your colleagues, that at some point they could discuss with you whether they'd be a fit for the early customer program or not.
Absolutely. Yeah, absolutely. And we've got a number of different ways that we could do a deployment with you. As we mentioned before, Modzy is built to go anywhere. So from cloud to on-premise to sort of tactical environments, we've got a lot of options. And we just love to talk with you.
Well, that brings us to the end of the discussion. So, Seth, I just want to say thank you so much for jumping on and having this conversation today. I hope this will be helpful to folks who are looking at the space, looking at all these different model ops and MLOps pipeline and platform tools that are out there. That market is exploding. And I was just so impressed when I looked through all the work that you guys are doing on your team and how comprehensively you're thinking about this problem and the solutions to some of the problems in the space, that I'm just thrilled that you were able to come on and we could have this discussion. And so I just want to say thanks for your time.
My pleasure, Troy. And it was great talking to someone else who not only appreciates the technology, but is also eager to learn more. I think that's something that we have in common. It's such an interesting space. There's so much to learn. And it was just great talking with you and kind of thinking out loud about how this technology can start doing something useful.
So that wraps the conversation. Thank you very much for joining me on the Productive AI podcast today with Seth Clark from Modzy. I'll see you on the next show.